This is my second video on applications of derivatives focusing on related rates. Let's have our first example. A 17-foot ladder is leaning against a wall. The ladder slides down the wall at a rate of 3 feet per minute. How fast is the ladder moving away from the base of the wall when the foot of the ladder is currently 8 feet from the wall? How fast is the area of the triangle changing? How fast is the angle between the ladder and the ground changing? So here in this example, we will be answering 3 questions. Let's have first the first question. So to answer our first question, how fast is the ladder moving away from the base of the wall when the foot of the ladder is currently 8 feet from the wall? So let us use this illustration here at the right. So let's plug in the given. We have 17 feet as the length of the ladder. So this is 17 feet. And also it says here that the ladder slides down the wall at a rate of 3 feet per minute. So the rate of the ladder sliding down the wall is 3 feet per minute. So what will that be? So if we represent this as our y, let's represent this as our x. So the rate of the ladder sliding down the wall will be the dy dt. And if the ladder is sliding down the wall, we can say that the length of y is decreasing. So we have negative 3 feet per minute. So we use negative. Okay. So what else is given for us? We have how fast is the ladder moving away from the base of the wall when the foot of the ladder is currently 8 feet from the wall. So our x value or the length of x here is 8 feet. And we are actually looking for dx dt. Okay. So what formula relates x, y, and this length of the ladder to one another? Let's represent this as z. Okay, we can use the Pythagorean theorem since we form here a right triangle. So we have the z squared is equal to x squared plus y squared. And this is what we are going to differentiate with respect to time. So we have 2z dz dt is equal to 2x dx dt plus 2y dy dt. So we can see that every term is divisible by 2. So let's make this simpler. So 2 z dz dt equals x dx dt plus y dy dt. And let's plug in the data that we have. We have a z that is 17. So 17 dz dt is equal to, we have an x value. Then we're looking for dx dt plus y, and we have a dy dt which is negative 3. So dz dt. So what can I say about dz dt? That means the change in the length of the ladder over time. So it will not change. It's a constant. So the derivative of z with respect to time will be 0. It will not change. Okay? So this one is automatically 0. And then we have the x as 8. And how about the y? So this y here, actually we can solve for it using our Pythagorean theorem here. So we have the z as 17. So 17 squared, we have an x that is 8. 8 squared plus y squared. So y is actually the square root of 17 squared minus 8 squared. And that is actually equal to 15. So we have a 15 here. So let's continue with this one. So we have 0 is equal to 8 dx dt minus 45. So we have 45 is equal to 8 dx dt. Dividing both sides by 8, we get dx dt is equal to 45 over 8, and that is approximately 5.625. And our unit of measure for the change in x will be feet per minute. So as we can see based on this problem, as the ladder slides down the wall, so the rate here is negative because the length of y is decreasing. But here we see that it's positive. That means that the distance between the wall and the foot of the ladder is increasing at that rate, 5.625 feet per minute. And for this question, this is our answer. Let's proceed to the second question. So it is asking for how fast is the area of the triangle changing? That would mean we will need the area of the triangle. So the area of a triangle is actually base times height over 2, or 1/2 base times height. So in this problem, our base is the x and the height is y. If you are going to consider this illustration earlier. So this is what we are going to have instead. So we have A, the area is 1/2 x times y. And this formula is what we will differentiate with respect to time. So we have derivative of the area over time is equal to, we can apply product rule here. So that will be 1/2 times y dy dx dt, because we differentiated x, 1/2 x in this first part of the product rule, plus, copy the first factor, 1/2 x, then derivative of y is just 1, but we multiply it by dy dt. So let's plug in the data that we have. We have 1/2, we have a y, we have dx dt, Okay, plus 1/2, we have an x, and we also have dy dt. So x was 8. I know, not there. X is here, that was 8. Y was 15. We solved for dx dt earlier, and that was 5.625. So 5.625, and dy dt was -3. So we just multiply everything. So we have dA dt is equal to, okay, multiply everything here and then add the product of this. Then we get a final answer of 30.1875. So that's how fast the area of the triangle is changing. So our unit of measure, since this is area, we use feet squared per minute. Okay, and this is our answer to the second question. Let's now proceed to the third question. So it is asking, how fast is the angle between the ladder and the ground changing? So the ladder and the ground, so this one. So how fast is that angle changing? So since we are dealing with right triangle, we can actually apply SOHCAHTOA that we learned in junior high school. Okay, so we can use sine, cosine, or tangent, but we choose the easiest. I think sine and cosine, they have the same level of difficulty, while tangent, since tangent means opposite over hypotenuse, that will be y over x, and that would mean you will have to apply quotient rule later on. So not that anymore. So we just choose between sine and cosine. So let's use sine. So our formula will be sine theta is equal to, so sine, that's opposite, so we have y over hypotenuse, which is 17, a constant. It's 17 based on the problem. So we just have sine theta is 1/17 y. So let's get the derivative of this with respect to time. So derivative of sine is negative cosine. I know it's positive cosine, sorry. Positive cosine theta, and of course derivative of theta with respect to time. So that's what we are after, the rate of change in the angle. So equal to 1/17. So derivative of y is 1. So dy dt. Okay, so let's plug in the given cosine theta. So cosine theta. Cosine is adjacent over hypotenuse. So our cosine theta is, so what's adjacent? That's x, and that was 8, right? The x value is 8. And then over the hypotenuse, 17. And then derivative of theta over time is equal to 1/17. Then we have the -3 earlier. So our derivative of theta with respect to time is just equal to -3/8 or -0.375. And our unit of measure, what will be our unit of measure here? So the standard unit for angle is radian, and that's per meter.